Hi guys, welcome back. We are going to be working today on, for those of you following along in the book at home, it's the Saxon Algebra 1/2, third edition. And we are talking today about lesson 4. We're going to do some multiplication and division. I'm actually super excited to talk to you about this today because you'll find that we do a multiplication. I'm going to show you 2 different methods of working on these. You'll find that, especially if your parents are watching, there's an old way of doing multiplication and a new way. And that new way is really helpful when we get into some more advanced algebra, but I'm going to show you today why we like to do that. Okay, so let me get situated here. There we go. Okay, so first things first, if you're following along at home, we're on page 15, and I'm going to take a look at the first example, which is, and I'm going to rotate this guy because we're going to do method number 1 for our example of 164 times 23. Okay, one thing here first is that we also have to talk about some vocabulary. These 2 things, when we're multiplying 2 things together, we call those the factor. That's our other factor. The result, the answer that we get, that's called our product. Okay, our product. Those are going to be good things. You should write those down in your notebook. I want you to write product equals multiplication. We're going to have a bunch of these words that mean different things. Sum means addition, difference means subtraction, product means multiplication. So as we go along, we're going to continue adding to that list. So you may want to flag that. Okay, that old school method of multiplication that we're going to do. I don't know why that auto adjusts. I'm really sorry about that. Let me see if I can't. I'm new to technology. I'm an old lady. I'm sorry, guys. Let me see. How about? All right, so the old way that we did things is we do 3 times 4, which gives us 12. Carry the 1. 6 times 3 is 18, plus 1 more is 19. Carry that 1. 3 times 1 is 3, plus 1 more is 4. Now we're starting on that second line, so we do a 0. 2 times 4, and I'm going to get rid of these guys. 2 times 4 is 8. 2 times 6 is 12. Carry the 1. 2 times 1 is 2, plus 1 more is 3. All right, bring everything down. We add up to 7, carry the 1. That's 6, 7, and 3. All right, so taking a look at this guy, we have, okay, so that's our first method of doing these. So we have now our second method. I gotta be real, I was just checking that on the calculator to make sure I didn't make a mistake. As I sit here and do these by myself, it's very easy to make a mistake and then not catch it. So I wanted to double check that. All right, so that was our first method. Your parents are probably really familiar with that method. You may even be familiar with it as well. This next method is called the box method. And I love this method, especially when we get into teaching some polynomials, that kind of thing. So it's 164 times 23. You will see that we have a 3-digit number and a 2-digit number. 3 by 2 means that we need to have a 3 by 2 box. 3 by 2 box. So here is our 3 by 2 box. Now for that 3-digit one, we have 164. For the 2-digit one, we have 23. What we're going to do is multiply each one and put it in the box. So 20 times 100 is 2 with 1, 2, 3 zeros. 20 times 60 is 12 with 2 zeros. 4 times 2 is 8 with 1 zero. 100 times 3 is 300. 6 times 3 is 18 with a 0, and 4 times 3 is 12. Now here, the reason why I like doing this is what we need to do now is add up all these different boxes. However, it's kind of easy to do it mentally when they're in this order. Like 2,000 plus this plus that, that's going to give us 3,500. 2,000 and 1,000 gives us 3,000. 200 and 300 gives us 500. Then we'll add up 180 and 80. That'll give us 260. If you can't do that part in your head, that's fine. You can just list them out. Then we got that 12. So that 12 in there. Add all these guys up, and we have The exact same answer here and here. So both methods are totally valid for however you want to do math. Like I said, this comes in handy when we start to do some polynomials. So, let me get my face a little shrunk there so you can see it. So this comes in handy when we do polynomials. So you may want to just practice it now, but either way, these are totally valid ways of solving multiplication. Okay, so on page 15, there's another example at 4.2. We're talking about $5. Oop, I said 5 and then wrote 7. $5.79 times 29. $5.79 times 29. Now, as far as invisible math goes, one of the things that's invisible in math are decimal places. If it's not shown, it's at the end here, and that's going to come up at the end. That's going to be pretty relevant. In the meantime, what we want to do, we're going to treat this like a normal multiplication problem and ignore the decimals. So really, and I'm going to use my favorite method, that box method, 579 times 29. All right, so I got my box of 3, because there's 3 digit by 2. I don't know why I can't draw a straight box. I'm very sorry about that. That was atrocious. Get a language lesson here at the same time. Atrocious means awful. Okay, so we have 579, 20 and 9. You may have seen these called like magic rectangles. I've seen that before, and there's some puzzles that you can do around that. I like them. So 2 times 5 is 10 with 1, 2, 3 zeros. 7 times 2 is 14 with 2 zeros. 9 times 2, 18 with a 0. 9 times 5 is 45 with 2 zeros. 7 times 9 is 63 with a 0. 9 times 9 is 81. All right, I'm going to shift over here a little bit so you can see. All right, so I have 10,000, and then I've got these guys. So I have 10,000. Let me just throw that down there so I don't lose it. 4,500 and 1,400. That is going to give us 5,900. Okay. Then we've got 630. Then we've got 180. Then we have 81. So we're going to add all these guys up. We have 1 here. 8 and 8 is 16, 17, 18, 19. Carry the 1. 9, that's 10, 16, 17. Carry the 1. 15 and 1 more is 16. All right, so we do all this math. We come back up to our original problem here, right? Let's get these guys out of the way. And our answer is 16791. 16791. Now here's where those decimals are important. We look at our two numbers that are factors that we started with, and we look at those decimals. This one, there's nothing behind the decimal, but here we have 2 digits that are behind the decimal. We have 1, 2 digits. That means over here, our decimals at the end, we need to move it in 1, 2. So our answer is going to be, and now I'm going to erase this so you can see this. Our answer is 167 and 91 hundredths. 91 hundredths. That is our answer. Oh, with the dollar, sorry. So that it's actually $167.91 because we have to deal with that dollar sign. Okay? So that's another way of multiplying. If you want to go back and do it the original way and you need help, let me know. All right. So that was the second example. Now, for the next part of this lesson, we're going to talk about division. Division. And there's a good description here in the book. Make sure you're looking through the book as you're going through these. Okay, so another word that I want you to write down is quotient. Quotient means to divide. It's the answer to a division question, okay? This is your divisor, this is your dividend, okay? Divisor, dividend, quotient. Quotient's the most important one on those. You don't have to write the other two down. We rarely use those. Okay, so for example, let's say that we can write actually division a bunch of different ways. So this is something you'll see. You may still periodically see this division symbol. I don't really care for that, especially now that you're heading into algebra. So instead, what I encourage is you to write it as a fraction, Now, if you do have to do long division by hand, you're probably familiar with looking at it like this, where we have that table, right? It's on top of the table here, it goes under the table here. So I prefer, get rid of those guys, and I prefer fractions or like this. All right, So taking a look at the example 4.3, what we have is 1370 divided 5 ways. Divided 5 ways. Okay, so what we're going to do here is 5 divided by 13, or I should say 1370 divided by 5. Okay, what we do is we bring our decimal up to here. 5 goes into 13 2 times without going over. 2 times 5 gives us 10. We subtract, and every time we subtract, we also bring down. So 5 goes into 37 7 times. 7 times 5 is 35. We subtract, we get 2, and we bring this guy down. So 5 goes into 20 4 times. 4 times 5 is 20, and we have no remainders. No remainders. Since we're starting with a dollar sign, it's really important that you end your answer with a dollar sign. Okay? So that would be our answer. Awesome. All right, so in a previous lesson, we talked about addition and subtraction patterns, where if you add one way, you subtract the other. This is also relevant for multiplication, okay? For example, if we have 12 times n equals 168. 12 times n equals 168. If we multiply in this direction, we can divide in this direction, okay? So if we do that, we would get 168 divided by n equals 12. I know I said not to use this and then I just did, but you'll see it periodically in pre-algebra, and then it'll pretty much go away completely in algebra. Okay, so we look at this, but that doesn't really help us, does it? That's because there's actually a different way. Multiplication is very much like addition. We can write it in any gosh darn order. So 12 times n is the same as n times 12. Just like if we did 7 plus 10, that would be the same as 10 plus 7. Any gosh darn order. It's a commutative property. Commutative property. All right, so I've rewritten this guy. Multiplication in this direction, division in that direction. That means I can do 168 divided by 12 equals n. And I'm writing it like this so that it's in straight lines so you can see. 168 divided by 12. Let's do the math on that. We've got 12 here, 168. 12 goes into 16. It doesn't go into 1, so there's nothing that needs to go there. We can even put a 0 there or a placeholder. But 12 goes into 16 one time without going over. We subtract, we get 4, and every time we subtract, we also bring down. 12 goes into 48 4 times. 4 times 12 is 48, so we have 0 remainder, which means our answer is, get rid of that 0 in the front, that placeholder, our answer is 14. 14. We can always go back and check our work here. 12 times, and we said n is 14, in fact, is 168, okay? Let's try one more of these guys. If you turn the page on 18, we've got another example here. We have 64 divided by a equals 4. All right, so I'm going to rewrite this so that you can kind of see it. 64 divided by a equals 4. If we divide in this direction, we can multiply in this direction, okay? Well, if we multiply in that direction, we get 4 times a equals 64. That doesn't really help us, does it? So we're going to need to reorder our division. Just like subtraction, we can reorder these last two things, okay? So 64 divided by 4 equals a. Well, that's something we can solve, right? We don't even need to turn it into a multiplication problem. So we're going to do 64 divided by 4. 4 goes into 6 with one time without going over. 1 times 4 is 4. We get 2, and every time we subtract, we also bring down. 4 goes into 25 times. 5 times. 5 times 4 is 20. Subtract, and we have a remainder of 0. So come back over here. Let's double check our work. 64 divided by 4 will give us 15. Okay. 64 divided by 15 will give us 4 because we can interchange those guys. All right. Excellent. Okay, what I want you to do is go ahead and pause the video. You're going to do the practice problems that are on page 18, A through G. Go ahead and pause those. I will write them down if you want. If you don't have the book in front of you, I'll write them down and give you a second to do those. We have 300 times $1.25. 300 times $1.25. Pause the video and try that. For the rest of you, we will go ahead and do this. Okay, now, a couple things here. If we have those zeros at the end, we can ignore those until the end of the problem and then just slap them on there. Very much like if we do 10 times 7, that's going to give us, what that really is 7 times 1 plus 1 0, okay? 100 times 3 is going to be 3 times 1, which is 3, with 1, 2 zeros. So same thing up here. We're going to ignore those zeros till the end. We're going to ignore the zeros, but we're also going to ignore those decimals, just like I showed you before. So really the problem we need to solve here is 125 times 3. 125 times 3. When we're done, we will slap those zeros back on, and then we will deal with the decimal. This is a 3 by 1, 3 by 1. So in this case, we're not going to do a box. We're just going to do our old school way. Boxes only really work if it's like a 2 by 2 or larger. All right, 5 times 3 is 15, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3. All right, we've got that. Don't forget we have 2 zeros to slap on there. Bam. All right, our decimals at the end here, we look at our original problem and we find the decimal here is at the end here. We look for how many digits are behind decimals. In this case, 1, 2, and that's it. So we're gonna come over here, we're gonna go 1, 2, and we end up with $375. $375. Now let's go back to the original. 300 times $1.25. Let's just estimate that, right? Ballpark figure. 300 times $1 would give us $300, right? 375. So I'd say we're pretty close. All right, that's a good way to estimate to make sure you've got the right answer. All right, so then for B, let's take a look at this guy. We have 778 times 563. 778 times 563. Go ahead and pause that and do that problem. All right, I'm actually going to write it a little bit higher. 778 times 563. Now, this is a big one, so I'm going to do the box method, okay? It's a 3 by 3 here, so we're going to do a 3 by 3. Just like a tic-tac-toe board, isn't it? All right, it doesn't matter if I put the 778 on the top or the side or the top. You can put them in on either side. But it's 778, and this is 563. All right, let's go to town on multiplying. 5 times 7 is 35 with 1, 2, 3, 4 zeros. 7 times 5 is 35 with 3 zeros. 8 times 5 is 40 with 2 zeros. 6 times 7 is 42 with 1, 2, 3 zeros. 7 times 6 is 42 with 2 zeros. 6 times 8 is 48 with a 0. 7 times 3 is 21 with 2 zeros. 7 times 3 is 21 with 1 0. 8 times 3 is 24. All right, so we've got some big numbers here. I think it's helpful to put in commas so that we know where we're at. So I'm going to throw a comma here, 1, 2, 3, comma there, 1, 2, 3, comma there, comma there, comma there. Okay, so let's start with that big number, 350,000. Okay, then we have 35 and 42. Well, 5, 6, 7, that's 77, right? So let's cross that out, that out, that out. 4,000 and 4,200 gives us 8,200. Okay, then we have 2,100. Then we have 480 and 210. That's going to give us 690. And then we have 24. All right. Got all those out of the way. All right, so make sure you line everything up nicely, otherwise it's going to be a pain to find. So we've got 4, and then we have 9, and that's 11. Carry the 1. 2 plus 1 more is 3, plus 6 is 9, plus 1 more is 10. 1 plus 7 is 8. 8 and 8 is 16. 17, 18. Carry the 1. And then we have 7 and 7 is 14. So 13. 7 plus 5 plus 1 gives us 13. Carry the 1. All right. Now we go back to our original problem. We have no decimals there, so we don't have to worry about anything. We get 138, 0, 1, 4, 138, 0, 1, 4, and that's 138,014. 138,014. All right, so, oh my gosh, you guys, I made a mistake. This is why I always double check. What's 1 plus 3? It's not 100, it's 4. So it's 438,000. Oh, the rest of it is right. Sorry about that. Okay, so 438,000. All right, that was B. This is why I double check while I'm working. All right, let's take a peek here. We have C. C is going to be 261 divided by 30. 261 divided by 30. Okay, so what we do is 30 divided by 261. Well, 30 does not go into 26. It's going to have to go into this whole thing, right? I know 30 times 10 is going to give us 300. This is a little less than that, so let's do some work here. 30 times 9 will give us 270. 30 times 8 will give us 240. So 30 goes into this 8 times without going over. 8 times 30 gives us 240. We do some subtraction here, we get 21. Are we done yet? No. What we need to do is add a decimal here, because remember in our invisible math, decimals are always at the end of numbers. And so we're going to bring that decimal up, we're going to throw a 0 at the end of here. So when we subtract it here, remember when we subtract, we also bring down. Okay? Subtract, we bring down. 30 goes into 210. Well, 3 goes into 21 7 times. So I'm going to say 70. Or not 70, 7. So 7 times 30 gives us 210. Right? Subtract that, we get 0. We have no remainder. So this equals 8 and 7 tenths. 8 and 7 tenths. Good. All right, so let's try D. We have 12, and then we have divided by, or we've got 4908 divided by 12. 4908 divided by 12. First, we're going to bring our decimal up to here, okay? 12 goes into 49 4 times, right? 4 times 12 gives us 48. Subtract that, okay? When we subtract, we also bring down. 12 cannot go into tens. We're going to do a 0. Okay, and we're just going to go ahead and bring right down like that, okay? Well, 12 times 9, let's do some math over here, gives us 8, carry the 1, we get 10. 12 times 9 will give us 108. So 12 goes into 108 9 times. When we multiply that together, we get 108. Subtract, we get 0, no remainder. Now, when you're writing this answer, remember we did start with that $sign, so our answer needs to end with that $sign. Okay, there's your answer. All right, that was D. We're going to do E now. E is 15 times C equals 180. 180. All right, remember, if we multiply in this direction, we can divide in this direction. Divide in this direction. Well, if we do that, we get 180 divided by C equals 15. That doesn't really help us. So that means we need to rewrite our multiplication problem, okay? How about C times 15 equals 180? Any gosh darn order we can multiply in, right? Now, we multiply in this direction. We divide in this direction, which means we have 180 divided by 15 equals C. That definitely looks like something we can do. If it's at the beginning, it goes under our table. So we're going to do 180 divided by 15. Okay? 15 goes into 18 one time. Do some subtraction here. We get 3. When we subtract, we bring down. We get 0. 15 goes into 30 2 times with no remainders. No remainders. So the answer to 12, the answer to E is 12. Sure enough, if we go back here and we look 15 times, and our answer we decided was 12, so 15 times 12 would give us 180. All right, so that was E. Let's do F. We have x divided by 3 equals 56. X divided by 3 is 56. I'm going to rewrite this as x divided by 3 equals 56. Okay? Divide in this direction, multiply in this direction. So that multiplication problem is 56 times 3 equals x. Well, that's something we can do. Let's go over here. 56 times 3. 6 times 3 is 18. Carry the 1. 5 times 3 is 15. Plus 1 is 16. 168. Sure enough, if we go back into this problem, put 168 divided by 3, we would get 56. So for F, 168. All right, and last one we have G. 368 divided by B equals 92. 368 divided by B equals 92. I'm going to rewrite this. If we divide in this direction, we can multiply in that direction, but if we do that, we get 92 times B equals 368. That does not help us. So let's try a different way. Let's rewrite our division problem, and we can do that by doing 368 divided by, and just like subtraction, these last two get swapped, equals B. Okay, 368 divided by 92 equals B. All right, so we can actually do that information over here. We have 92 divided by 368. Well, 92 can't go into 36, it's gonna have to go into the whole thing. So let's do this. 92 times 3, okay, that gives us 6 and 270. 92 times 4 gives us 8. And then 36, I don't know why I stumbled there, 368, that's actually what we need, so 4. All right, so we come back over here, B equals 4. And sure enough, if we take 368 and we divide it by 4, we would get 92. Great work, guys. If you have any questions, let me know. Otherwise, I look forward to seeing you again. Thank you so much.